Good afternoon, guys. Welcome to B-Sides Las Vegas ground floor. You guys made it. So uh, we're going to have the talk titled Avoiding Credential Chaos, Authenticating Without Secrets. We have two speakers, Chitra, Dharmarajan, and we also have Steve Jarvis right there. So before we go ahead, we'd like to thank our sponsors, especially our diamond sponsors, Adobe and Aikido, and our gold sponsors, Formal and DropZone AI. It's their support, along with our other sponsors, donors, and volunteers that make this event possible. And a few of the other announcements are these talks are being streamed live. And as a courtesy to our speakers and audience, we ask that you check to make sure your cell phones are set to silent. If you have a question, use the audience microphone so YouTube can also hear you. Make sure to point at the mic in the audience so people know where it is, and that'll be the speaker ops. As a reminder, the B-Sides LV photo policy prohibits taking pictures without the explicit permission of everyone in frame. These talks are all being recorded and will be available on YouTube in the future. And with that, let's get started. So please welcome your speakers.
Hello, everyone. Good to see a room full of audience, completely filled with lunch here. So let's have some thoughts to share. Avoiding credential chaos, authenticating without secrets. That's a topic me and my colleague Steve Jarvis is here to discuss. A quick introduction. I'm Chitra Dharmarajan, VP of Security and Privacy Engineering at Okta. I love building high-performance teams across the globe, leading security transformations. Outside of my day job, I also advise many startups in Bay Area. And I love to grow along with technology and innovation these startups bring to the floor. And my security mantra is all about being an enabler, never be a gatekeeper in the career of security. And I have dropped my LinkedIn here, and I'm calling my colleague, Steve Jarvis, to give his stellar introduction.
Yeah, hi everyone. My name's Steve Jarvis. I'm a security architect at Auth0 at Okta. And before I was in this position, I spent a long time software engineering on network and security, building software in that space. And that still frames a lot of how I think about security now. Outside of work, I spent a lot of time cycling. I'm a dad to a 4-year-old, and my favorite thing is cycling with that 4-year-old, actually. So my security mantra is the secure way has to be the simple way. Otherwise, there will become another way if it's not the easiest way. And that's a link to my personal site at the bottom. Once we're done here, I'll put the resources up there too. So.
Thank you, Steve. And a little known fact about Steve. He has strong opinions about identity and even stronger opinions about bicycle tires. So if there are any bicyclists here, racers here, you have a subject matter expert to exchange thoughts. Okay. I want to say, your secrets are safe with us. This is a very safe space. Let's come clean. Let's share your secrets. Me and Steve has taken a pact to keep it safe with us. So in today's agenda, we are going to enable you to break up your relationship with shared credentials and secrets. We'll start with something like, you may be wondering, what's wrong if I have a few secrets? We keep them safe. No offense. It's just a little old-fashioned, and that's about it. And a lot of operational toil, secrets rotations. Then you may come to realize there are too many secrets that you have. Even your secrets may be having little secrets to keep. So how do you actually get rid of them? It's too much out of hands. That will be our second phase of discussion. And then we all will make together an executive decision to get rid of them. Time to break up. And we make that decision together. And then we as security practitioners, we only believe what we see, right? Proof is always in the pudding. So there are going to be some cool demos about cross-cloud authentication without secrets. And finally, we leave this room in peace, knowing that our secrets are safe. Oh, wait, there will not be any secrets to safeguard. So we will be more at peace knowing that our secrets are cleaned out. So that's the goal and agenda for today's discussion. So enough having all that fun. No tech talk can start without some scary data points and numbers, right? So a global average cost of any data breach as of 2024, citing from Thomson Reuters, it's about 4.88 million is the cost for every single breach, and this is a global average. And I'm sure it's more than that, but this is what the industry has called it as a code. But just within US, the cost of an average breach, of a single average, cost of an average breach is about 10 million. And the cost increase is due to a lot of expenses with detection tools, credit monitoring services, regulations, fines, and everything. These are some tangible costs, but there is also a lot of intangible costs. This is more about loss of customer trust, employee anxiety, productivity, down leveling of the productivity, a lot of security operations work, and last but not the least, cost increase with cyber insurances. Most of the data breaches, they start with lost or stolen credentials. So let's understand the attacker's tactics so that we can strengthen our defenses. Most of the data breaches start with, either it's a compromised credentials, lost or stolen credentials, or harvested list of credentials from prior attacks with the aid of bots. Victim service or victim themselves are targeted for attackers' successful access and thereby the data breach. So before we go into the detailed discussion of this session, we all want to remember a golden rule. Thou shall not have the burden of any secrets. Let's call it out in our brain one more time. Thou shall not have the burden of any secrets. Like any golden rule, there is always going to be a caveat, right? So if you must have a secret, make it a point that you have it secured in HSMs or KMS and have some automated rotations put in place. Let's say you may still need to have some secrets in your environments for your bootstrapping of your infrastructure, whatsoever reason, whatever may be the reason, if you still want to keep some secrets, then we need to choose what we need to keep, and we need to bake automated rotations as a part of our security operations. Not when a bad day happens, it should be like everyday operations, like every 4 weeks, 6 weeks, when you do blue-green deployments, whatever you can rotate, you should be rotating to maintain the security posture. So rain or shine, we rotate them on time. If you plan to keep a secret, that's a liability we own. So with that preamble, let's think about a regular work day in a technology company where we have employees logging into their SaaS applications like Confluence, Slack, GitHub, and the CI/CD pipeline, deploying the workloads in your cloud infrastructure, SRE engineers accessing EC2 instances via SSH keys, and of course, services accessing many of the resources via API token. Seems like a typical IT work day, right? This infrastructure is fully infested with a lot of risky secrets. An employee using a password instead of corporate SSO, and SRE engineer using an SSH key. Maybe they store them in their laptops, you never know, or the AWS config files. And service-to-service communications between Kubernetes microservices via shared secrets. And those API tokens, there is credentials everywhere. Anything that get logged via logs, anything that get harvested out, your production infrastructure is at risk. So, Steve, what do we do about this? How do we go from here to a clean state or the target state of secure infrastructure?
Yeah, thank you, Chitra. You might have to mute because I think we're getting feedback. So.
Okay.
Yeah, thanks, Chitra. So what are we going to do about it? Well, the goal here is that we're going to move one piece at a time, basically. We're starting with this picture on the left, which is our current state, how we're operating right now in our imaginary company. And we're going to try to get to this picture on the right. And the general idea is that, red, bad, blue, good. So we're going to see how we can change these different components, the way they're authenticating with each other, how we're managing these secrets, and dramatically reduce the burden that we're feeling. And we're going to go about this in 4 areas in particular. The first, we're going to look at the engineer's access to SaaS and servers. And then we're going to look at how our CI/CD, which is also in GitHub, and in this picture, GitHub is going to serve as both our version control and our continuous deployment, how that's accessing the cloud infrastructure to deploy resources. And then third, we're going to look at the API access here from our services. Our services need to talk to that API we're operating. And lastly, the communication of those services between Kubernetes clusters. Okay? And at each step, we'll suggest a different design, something different we could do, how we can improve the situation. So first, we'll check out the user auth. And this initial one is probably going to be familiar to just about everybody. Right? Passwords are so yesterday. So what we can do instead of a password is we can use some public-private key technology like WebAuthn, add an IDP to consolidate identity management, and we don't have those static persistent credentials around anymore. So for example, in WebAuthn, right, your device creates and generates a private key. And that private key is used to sign proof that you are you. Requiring a biometric to use that key to sign that assertion or that challenge is like a built-in second factor. So we get MFA automatically in this flow. And one of the big pain points originally with this was that private key is strictly bound to your device. So if you made an account on your phone, you couldn't log in on your laptop. And that was really not workable. So back to the secure way has to be the easy way. This never caught on because that's a huge pain. So passkeys address this and syncing it to different devices. So this burden is largely gone now. We can use passwordless authentication. It's got built-in MFA, and it's a huge improvement, right? Because now in the login flow, that key, it never leaves your device. You couldn't leak this. It can't get phished. It can't leave. So, and also, assume there is a data breach at the provider, right? Like Chitra mentioned, that's like a fuel for a lot of this security incident cycle. If there is a breach and that database gets lost, they have the public key. They can't impersonate you the public key. So even if there is worst case breach, it's still relatively all right. Okay? So this is a quick win for our golden rule of not carrying the burden of secrets. We just offloaded a bunch of passwords to be the device's responsibility now. So the second thing we're going to look at is still in that engineer access. And right now, if we have an incident and we need to access some servers, we're relying on SSH keys. So this really means that every engineer that could possibly respond to an incident, which is typically all of them, are going to have a key on their laptop that probably lives just about forever. Right? So we're going to build on that same authentication flow we already have to leverage that IDP, but now we're going to use it to assume roles in AWS, temporary credentials that live for a short time, and combine that with a native service in AWS called Session Manager. So now we don't have a need for a secure shell session here. Session Manager is going to use AWS's APIs locally to establish a shell that the engineer can use in that environment. And so not only here are we eliminating some of the risk that we were carrying from these static credentials, we actually get to harden the host at the same time because now we don't need any ports open to the internet. Okay? And this is a very AWS-specific picture, but again, like the things we're painting here are just for example purposes. The other major cloud providers have the same concepts available, right? So quick recap, we're moving through this picture really well. We've already kind of made a happy story out of all of the engineer's access, right? There's no secrets that we have to worry about in that part of the picture anymore. So now we're going to move a little bit right over to the CI/CD. And again, that's in GitHub's workflows. And that's what we're using to actually deploy our services to these clouds. So what we've been doing so far in GitHub workflows is provisioning static secrets, right? For deploying the AWS services, we have IAM users, access keys. To get stuff into Azure, we have the client ID and secret for a service principal. And those workflows, pull those secrets out of GitHub Secrets, deploy the infrastructure, and that all works all right. But we would love to not need to provision these, right? So what else can we do? Well, in this case, GitHub can actually act as an OIDC issuer, right? It will sign tokens for your workflow as a feature of GitHub. And so now we can kind of use that as the identity provider to assume these IAM roles and onto service principals. And we don't need to provision any secrets anymore in GitHub. All we need is configuration. It needs to know what IAM role ARN to look at, what service principal to look at. We need to establish the trust in these clouds to say, we have an IAM role here. And if I get a token, an ID token from GitHub, it's allowed to do whatever this IAM role is allowed to do. It just becomes configuration. There's no more secrets in the picture. And we can and should lock that down to the specific GitHub repository and branch, and you really easily have that level of specificity when you're defining those rules. So, more quick progress. We've got a great mechanism for our human users. No more secrets there. Our CI/CD has limited the secrets from those workflows. And now, I suppose we should check out what our actual services are doing, what we're building, how are they communicating with each other. So if we go all the way to the right side of the diagram here, we have this service running in Kubernetes and Azure connecting to an API with an API token. So an API token here, this is a pre-configured shared secret, probably has an indefinite lifespan. And there's a lot of risk here because if this is transmitted as it is across the way, right? It exists in the same state on the client as it does the server. If we ever have a software bug or a logging error on either end of this, we're going to put that API token in a log somewhere. Any software vulnerability, we could leak it. We would really love to change this. So what else could we do? Well, we can use some more private key technology, right? And we're going to do something called a private key jot. And what that looks like is we generate a public key pair. Our service will sign attestations with that private key and submit them to our IDP. That IDP knows about our public key, so it can verify that we are the client that holds this private key, right? I trust this. We're going to give you a token, and it will issue an access token. That access token is what we can pass then to our API. And this access token is short-lived. It can live for hours, minutes, like how long do you need it? And we could very easily run through this flow again to refresh it. So now if we have a problem, and this key, this access token that we're actually submitting to the API ends up in a log or ends up breached, there's a very good chance that it's expired by the time anyone's able to do something with it, right? And that's actually not all. There's another really cool little win we get from here besides just the secrets management benefit. Because this is fully like OAuth 2 and we're getting a JOT issued from an IDP, now we can also leverage custom claims and scopes here at the IDP. And those end up embedded in that access token. So before we had like a really opaque generic API key that get passed back and forth. Now we have an ability to define authorization values, right? Scopes, claims in the token at that IDP. So we've like gotten more power to our kind of IT administrators to control exactly what this service is allowed to do at the API. Not just that it's allowed to access it. Now we get more knobs to turn here. What ends up in that access token? What do we want to enforce? So cool. With that change, we're 3/4 of the way through the specific topics that we wanted to fix, right? We have removed all the credentials that the engineers had access to directly to access the SaaS and the servers in the cloud. Our CI/CD is like happily humming along with no provision secrets. And the services that we have running in Kubernetes and Azure, they no longer need a static API token to interact. The last thing that we want to look at is the communication between these two services. We have clusters running in each cloud, and we want them to be able to talk to each other. Right now, those two services are using pre-shared secrets to communicate. And this is working. Right? It just means nothing magic about this. We just developed whatever, a 30-character magic string, and we make sure everyone knows the same one, and then they can talk to each other because no one else would know the same thing if we didn't put it there on purpose, right? And that works, but it's really actually a pain on redeployments, on fallbacks, because this is a distributed system. So we're trying to update. If we have to do rotation, we have to update this pre-shared secret at a bunch of disparate clusters, right? It's a difficult thing to do, and it's causing us a lot of heartache. So we would love to change this to rely on some PKI and mutual TLS. And we can use the certificates that are issued to these workloads to establish that identity and that root of trust. So then the real anchor of trust and the long-lived key is no longer these pre-shared secrets. It's the root CA private key. And that we can store in something like an HSM. So it will just issue in real life. There would probably be more levels here. It's not going to be the root just issuing search to the cluster, but say we have an intermediate here. But the point is this one's locked away in an HSM or even something physical like a bank vault. We have intermediaries. And then these ones that are used as identity for the services in the cluster, we can rotate those on every deployment. Every time we ship out a new cluster, just change it every time. So like it doesn't become an event to rotate anymore. It just happens. It's a normal day. We're shipping an update. We're going to get new certificates issued.
So Steve, not every infrastructure is mature to do the MTLS authentication, right? This requires a lot of service mesh configurations. So what are the other mechanisms that we can secure the service-to-service communications?
Yeah, good question. And that's fair, because this establishing PKI, we have to do device attestations. There's probably, like you mentioned, service mesh to actually control the access policies. There's a lot of prerequisites for something like this. So instead, yeah, sometimes we don't really need a BMW. A Camry is perfect. So thank you. We can improve the situation a little bit using this pre-shared key that's already present. So instead of passing that pre-shared key directly, we can use it as part of a building our own JOT, basically, or JWT token. We can put the values that we need in our own JOT, and we can use something like Happy's iron module with that pre-shared key to both provide integrity and secrecy to that. We'll authenticate and we'll encrypt that JOT. And on each side, we have that pre-shared key. We'll be able to seal it on the sender, unseal it on the receiver, and then we get a little bit for improvement. Like it's admittedly a modest improvement over compared to something like a full PKI and MTLS, but it's for quite low cost. I'm calling out. So yeah. Yeah, so it's a simple improvement. We do improve the picture here by using something like an iron token.
So Steve, as a part of this conversation, we are supposed to walk the audience through a very cool demo, right? We are supposed to talk about cloud-to-cloud resource access via authentication with no secrets.
Yeah, first I want to touch on actually the difference between, why is this still an improvement? Because we're still burdened by these secrets, right? So yeah, we'll get to that in a second. That's good. But first, when we started talking, we talked about how we're going to remove these secrets from our system. And now in a couple places, like here with this pre-shared key, we didn't actually remove it. And before, if you remember, we were talking about the access to the client API. We just exchanged an API token for a private key. We still have stuff we have to take care of, but we're really reducing the burden. And we actually are, because in situations like this, they never leave the host. A private key or this pre-shared key now, it never leaves the service that it's provisioned for. It doesn't go over the wire. It doesn't end up on a server. And the token that does get sent is short-lived. Right? So if there is an issue, it'll expire quickly. We can rotate without worrying about a broader, longer-lived impact. And private keys we can lock away relatively more securely, HSM, KMS, something like that. So even though we do still have secrets, we're making better choices about the types of secrets that we have. how we rotate them as a regular part of deployments, and how we store them and manage them. So even though some still exist in our system, they always will, we can make better choices about what they are and how we treat them, and still significantly reduce our risk. So in the end, we end up with a happy all blue picture, right? We have all the connections we did originally, all the services are doing the same functions they were, there's the same authentication going on, but in this state, all the secrets are managed by like the IDP, stored in HSM. There are credentials that are in the system but rotated as a regular course of, say, our deployments every week. And it's a much better spot to be in. It feels good, right?
Yeah, we still need to. Yeah, we still need to walk our audience through that cool demo.
That's right, we do.
Yeah, so do you think all we talked about is securing access of users, CI/CD, service-to-service authentication, but many tech infrastructure is all about multi-cloud ecosystem, right? A service running in one cloud accessing a resource from another cloud and vice versa. So do you think we can federate identity in inter-cloud communications?
Yeah, good question. I do. So let's look at that. I think we can extend this a little bit because this is a common use case. So I love this. This is, say we have services running in one, and how do we authenticate to APIs in the other? So this is a little bit different than the inter-service communication we just had. Now say that we have maybe like a management plane that's running in one cloud, and we need to reach out to the APIs of the other, right? How can we federate across clouds without secrets here? So that's what we have. And there's kind of two different mechanisms we're going to talk about doing this because it's going to go in both directions. So on this side here, we have Azure running Kubernetes on AKS with a single container. And we want that to be able to assume an IAM role in AWS. And then, again, all the rights and privileges that IAM role has. On the other side here, we're running, again, Kubernetes on EKS in AWS. And it starts out the same. Kubernetes is going to issue a service account token to this container. And that's just a feature of Kubernetes natively. So that part's the same on both sides. But on this AWS side, we have more components. And the reason for that is in both of these situations, when Kubernetes issues that service account token, the issuer, or that trusted identity, is going to be tied directly to the cluster ID. And that might be fine. But if we're talking about hundreds or thousands of clusters or redeploying them regularly, now we have a new problem of like, how do we, here, we need to know what ID we're trusting. And if that's changing every day, they might be able to manage that, or maybe not. So the point here with these extra components is we ultimately get an ID token issued from Cognito. So if we think about this in like layers of the infrastructure, we have say in Terraform, we have the infrastructure that defines things like the ID providers, the clusters themselves, the IAM roles. And then we have Kubernetes, the actual manifests, and that's where we're going to find what services are running, how those AKS and EKS clusters are configured. And then we have the actual applications. And some of the challenge here is that when we change that, like redeploy the Kubernetes cluster, it has ties to the infrastructure level configuration. So we would need to manage that a little bit differently. By introducing Cognito as an issuer there, what we get is a stable, trusted issuer in AWS that is separated from the EKS issuer. Does that make sense? So we've kind of broken the intrinsic tie between this and ultimately what Entra has to trust. Cognito will stick around across cluster redeployments. Right?
So in this case, Cognito is helping us persist the ID that's being federated across the cloud.
Exactly. Yes. Yes. So this is running now. And what we're going to do is we have 3 problems at key points. So this is all set up. This is running. And we have 3 issues. The first one is from Azure, just trying to assume that IAM role. We have a bug with that role assumption. The nice thing is the Azure to AWS story is pretty simple. There's only one hop, so that's where the problem is. We know it is. In On the AWS side, we have two more problems. One is we get the service account issued, but we're failing to assume that IAM role with IRSA. IRSA IAM roles for service accounts is an AWS service feature. And the third one is actually being able to get that ID token from Cognito. So give me one moment. I'm going to switch to mirror mode because I'm going to actually really do this live, but I can't see what I'm typing on this mode. Have a mouse. Where'd my stuff go? Okay. Okay, great. So this is running. On the top left, in this pane, we have the live output from the cluster or from the application running in AWS. And on the right, we have the output from the app running in Azure. All right, and we're going to start with the one on the right. So we see it has failed to assume the AWS role. There's no OpenID Connect provider found for this issuer. Okay. Like I said, this is kind of the issue of the cluster ID changing. This format looks like this is the subscription ID, and this is the cluster ID. So every time we redeploy the cluster, fail over, roll back, that's going to change. And now we're going to actually look at the source code for this. And this is split up in the same kind of hierarchy I described it earlier. We have Terraform defining the infrastructure. We have Kubernetes manifests defining, what Kubernetes is running. And then we have a couple Python apps, one running in each one. And the goal of those applications is simply to assume the role and dump something about the identity in the environment just to show that we have the desired access, right? So the first issue here is that this issuer was basically the last version of our Azure cluster, right? We redeployed it. We forgot to change this. So I'm going to comment that out. And in this case, I have the correct value provided as a variable because, of course, this is all defined in one repository. I'm just deploying it here so I know what the correct value is already. So once we redeploy that, I'd expect the logs on the top right to automatically correct themselves. So what's going to happen is this: I have make targets, so I don't have to think too hard here live, but it's just going to run a Terraform apply right now. And that will fix the IAM role identity provider, or specifically the IAM identity provider that's allowed to assume this role to match the actual cluster ID that we have running over there.
So with every blue-green deployment, if we reconfigure the issuer ID in the other cloud, federation makes it easier.
Yeah. Yep. Yeah, and this is something that could be, like, I'm automating it here. There's a solution here. I don't mean to overcomplicate AWS. There's probably a fix on this one too. There's just going to be trade-offs, whichever way you want to go. Okay, so that'll turn green if it doesn't make me a liar. Should have made it sleepless. Yay, green. So now we see we have the issuer that we changed it to. And then the proof in this pudding is that we assumed the role or role in AWS. That's just a call to STS who am I, right? Okay, so now we're going to keep going on. We're going to look at the second issue here over in AWS land now, because now Azure's working, we're going to shift our focus to AWS. And here, we see that we are not authorized to perform that assume role with identity. So we have a Kubernetes service account. We want to change it into an IAM role, and we're not authorized to call that. This one's a little bit more opaque, but again, I get the advantage of having written these bugs on purpose, so I know to look in the service account annotation that we put on Kubernetes, because this is how you assume a role with IAM roles for service accounts with IRSA. You add an annotation to the pod for a role that your Kubernetes pod is allowed to assume. And in this case, we have the wrong ARN. And we know that because wrong is in the name. So again, looking at the EKS config here, this is another relatively simple mistake to make, but we're going to change that annotation to be the correct ARN for the role that we're actually allowed to assume. We're going to deploy those apps, and so make deploy apps, that's going to apply that Kubernetes manifest that we just updated. And then a refresh is simply going to scale down the deployment and scale it back up, so I force it to take up the new config, deploy a new pod, take up the new config. While that's thinking, I'm going to just start talking about the third. Okay? We'll come back to that in a second, because it should just take a minute. So the third problem here is once we fix this problem, we'll actually have an IRSA role that's allowed to use Cognito. And then we want to make the call to Cognito to say, hey, I'd love to get an ID token from you with that nice stable issuer, and then use that to assume service principal and Entra. And for this final problem, we're going to move up to the application level. We have a couple Python apps here. And the problem here is going to be pretty simple. Basically, we have that service account token that's issued by Kubernetes. Kubernetes issues that prefixed with the protocol of the issuer, HTTPS. Cognito doesn't want the issuer. It just wants the domain and the rest of the URI. So we're just going to get rid of it. And that's that. Once we have that, Cognito should happily issue us an ID token, because we're saying then that we want to use that login, the issuer that you expect, that we've configured you to be allowed to issue an ID token to. And here's ours. But first, let's check to see if we got past that last problem. Yeah, so before, we still have a problem, but before we were not allowed to assume role with web identity. Now we have a role. Now we just have an invalid login token. And obviously, if I check the service account annotation again, we should see it updated to be the actual EKS workload role that's allowed to be here. So one more bug fix for this final step, and it should light up all green. Thinking for a second, I changed the application, so what I need to do is rebuild the containers and push those to the registries. So this is actually going to build into an image locally, push to ACR and ECR, and we should be set there. Okay, since this is going for a second, why don't we move on to the learnings? Pushing was quicker before. A lot of people in here. So that's all right. I'll move on to some of our takeaways here, and we'll come back and check on the status of that in a second.
So the key takeaways which we want to reiterate for the audience here is, thou shall not have the burden of secrets, the golden rule, right? So it's incumbent upon us to design in a way to remove static credentials wherever possible. Let's say if there is an opportunity to leverage passwordless solutions for people login, be it SSM or passkeys, go for it. Utilize managed identities and trusted IDPs for service-to-service communications. Service API communications. And service-to-service communications, whether it could be an MTLS or some kind of IAM tokens where the shared secrets is not sent across the communicating entities. So coming to the second part, the caveat number 1, if you must have a secret somewhere, thou shalt secure the secrets, right? Think about HSM or KMS. Think about securing them with the hardware protection there. And if you must keep some secrets in some environment somewhere, for whatsoever reason, it's incumbent upon us to make sure that we frequently rotate them. So choose the right secrets to keep and bake them as a part of your regular rotations in your operations. So let's keep these golden rules in mind when we build our systems, when we build our infrastructures. Yeah. Thank you.
Awesome. Yeah, thank you all. And I'm definitely going to show this all green in a second, too. And I can't. I'm not going to leave it broken.
Live demo is always tricky one. Like, Steve, you did it awesome.
Yeah. Any questions or thoughts, or I'll just talk for another minute. Yeah.
Hi. Could you explain a bit more about those iron tokens and how they work? I'm guessing they're just like a certificate?
No, the iron token is going to do like a password-based key derivation to generate keys based. You give it just a string, a random string that you share on each side, and it will generate the keys necessary to do the crypto for the authentication and the secrecy, kind of on the fly.
Okay, thanks.
Yeah. Screen. Sorry, I just put that. So anyway. All right. Thanks, everybody.
Thank you.
Thank you, guys.